All right, geometry, lesson 35. You're going to learn two formulas today. You're going to learn how to find an arc length and how to find the area of a sector. They're two formulas, but they're based upon formulas that you already know. So they shouldn't be that hard to remember. But we do want to recall from lesson 26 that that minor and major arcs of a circle are parts of the circle's circumference. Right? They're lengths around a circle, but don't include the whole circle. The length of these arc segments can be determined if the circle's radius and the arc's degree measure are known. The arc length of a circle is the distance along an arc measured in linear units. So, for instance, let's say I took a sheet of paper, right, and I roll it around the outside. Arc length is telling me what is the distance around this circle. So the interesting thing about that particular question is that this is an 8.5 by 11 sheet of paper. The length of the paper is the same as the circumference of the circle, right, because the two ends meet. I think there's a question eventually that talks about that. All right, so now we're going to get into some formulas. You're getting mainly two formulas. One is arc length. How do I find the distance from A to B as a minor arc? And just simply put, we use the circumference formula. Circumference of a circle is what? How do I find the circumference of a circle? What? Yeah, but we want to use the radius here. So 2 pi r would give me the distance around the entire circle, right? Do we remember that? Okay. So, but we don't want the distance around the entire circle. We only want a fraction of it. And so what we use is the measure of the central angle or the measure of the arc, and we set it over 360. And that tells me what fraction of the circle I want to find the distance for. Okay? And my units are whatever units my radius is in. Okay, does that make sense? Okay? So we need to know arc length uses this formula. Okay, you're going to get a SMART goal stuff that's going to deal with this. So this is something that you need to know. Okay, it is the distance from here, if I'm traveling along the edge, to get to there. Okay. Arc length would be, whenever you walk outside, the earth as a circle, right? When you walk across the surface of the earth, you're measured in arc length. It may seem flat. It's not really. Okay? And then we have area of a sector. So every arc on a circle encompasses a portion of the circle's interior. Imagine it as a piece of pie or a piece of pizza or something like that. We're asking the question, what is the square inches of a slice of pizza? We can use this in order to find that out. Okay, so every arc on a circle encompasses a portion of the circle's interior. The region inside a circle is bounded by 2 radii, right? Because they start from the center and go to the outside edges of the circle. So every sector has 2 radii of the circle, and their intercepted arc is known as the sector length, or sector of a circle. Finding the area of a sector is similar to finding arc length. Okay, we still use measure over 360. Do we remember how to find the area of a circle? Pi r squared. So we're going to use that formula to find the area of a sector, except I don't want the entire area of the whole circle. I only want a portion of it. So I'm going to use that measure again, whatever my arc is in degrees, over the total number of degrees in the circle, which is 360. So you really haven't learned 2 new formulas. You've just learned 2 ways to use old formulas, right, with a little bit of a change on it. So area of a sector uses the area of a circle formula times the fraction of the circle, right, or the measure in degrees over 360. Right, arc length, 2 pi r, measure over 360. Does all this make relative sense to you? I'm not getting a whole lot of facial reaction, so it's hard to tell. Okay, so that brings us into doing some questions. Let's see, I kind of hope that I've got, let's see, let's try this. All right, so if we want to know the area of a sector in square units determined by an arc with a measure of 80 degrees and with a radius of 10, okay? So what formula do I use, Jackman? Measure over 360. Okay, very good. That's the formula I want to use. So I'm going to use pi. What do I use for my, or what is my radius? 10, so we got 10 squared. And then what over 360? 80. So we can reduce that fraction. What's 10 squared? So I got 100 pi. Does anybody know what 80 over 360 is? I'll give you a hint. We can drop those zeros off. 8 over 36. How about, let's see, both of them are divisible by 4 though, right? So it would be 2 over 9, right? Okay, so what's 100 pi times 2? 200 pi over 9. So if I want to get this to the nearest tenth, I'm going to wait till I get to here before I plug that in my calculator and get a decimal answer. Okay, so if I do that, let's see, I think I might still, yep. So I'm going to type in, clear some things out, 200 pi divided by 9. That's going to get me, let's see, they wanted to the nearest tenth, 69.8. And I don't know if they told me, they didn't tell me what my units were, did they? So 69.8 units squared. Somebody want to scroll down to the bottom and see what the answer key answer says on that? Okay. So I wish that they would use units because we don't want to. Obviously, there is a unit to this. All right, searchlight rotates. Some of this is just understanding what this is talking about. A searchlight rotates 60 degrees through a circle that has a radius of 110 feet. Now, it does say in here, what is the area of the searchlight that it covers? Let's see, Bryce, what formula am I using here? Read it closely. Area.
Oh, area of r squared and
Okay. What radius am I using? 110. Okay. We want to square that. What's the measure that I'm using over 360? Okay, so we got 60 over 360. Okay. Let's see, 110 squared. That's going to be something pretty big. What's that? 1,100? 1,100? Is that right? Or no, it's probably not right. 12,100? 110 squared is 12. Okay, yeah. 12,100, you say? 12,100 pi. All right, 60 over 360. We'll cancel out the zeros, and I should get what? 1/6. All right, so that's going to be 12,100 pi divided by 6. We want to the nearest square foot. I'll let you get me an answer, Bryce. 6,335.5. All right, well, we'd probably take that up to 6,336 feet squared. Scroll down to the bottom, see what our answer is on this. Question number 2. Is that it? Perfect. Good job. Let's see. This one is question number 3. Looks like a 34. We don't need to do that question. That's from the other lesson. All right, let's look at an arc length question. Let's see, Jordan. It says find the arc length L of a circle with a radius of 6 feet, arc measure of 120. Give our answer in terms of pi. That means that we're not going to plug pi into our calculator, but can you give me my formula for arc length? Well, they both have that. You got notes? Let's look it up. Arc length. What is that formula? Okay. All right, so we're going to use 2. We're going to use pi. What's my radius?
6.
Okay. What's the measure over 360 I want to use? 120 over 360. Okay, what's 2 times 6? So I got 12 pi. All right, let's see if we can reduce 12 over 36. Mm-hmm. Yeah, that's 12 divided by 36. Okay, do we know what that is as a fraction? Okay, so 1/3. So we want to take 12 pi times 1/3. What's 12 times 1? So that would give me 12 pi divided by 3, right? Okay, can we divide 12 by 3?
Yeah.
What's that leave me with? 4 pi. And because we have units, that's 4 pi feet, not squared, because we're looking for length. Okay? All right, so does everybody understand what they mean when they say solve in terms of pi? Okay. All right, we've done some area of a sector. We can solve in terms of pi. All right, do you guys feel like you understand this well enough to be dangerous and get started? Okay. All right, I'll shut it down right there.